the last two free response questions and all of the multiple choice questions for the kinetic practice set. I'm just going to work through them really quick, and hopefully y'all, won't have any problems with them. So this first one, let me get my pen back, says determine the order of the reaction with respect to each of these following reactions. So for the first one, for the nitrogen monoxide, oh come on. For the nitrogen monoxide, we're going to use experiments, looks like 1 and 3, and you want to indicate that. So using experiments 1 and 3, and then we'll fill it in there in a second. And so that's going to work out to be 0.06 divided by 0.02. These are these concentrations right here, raised to the m power. We're trying to find whatever m is going to be equal to our rates. So this rate divided by that rate. So 7.67 e negative 1 over 8.52 e negative 2. This works out to 3 raised to the m power. This works out to 9 when you plug it in the calculator. Therefore, 3 raised to what power equals 9? M has to be 2. So using experiments 1 and 3, NO is second order. And then going on to the O2, looks like we're going to be using experiments 1 and 2. So using experiments 1 and 2, and then we'll fill this in a sec. So we're going to put oxygen is 0.09 divided by 0.03 raised to the n power is equal to, the first rate is 2.56 e negative 1, negative, and then on the bottom is 8.52 e negative 2, and so this again works out to 3 raised to some power is equal to 3. Therefore, n is equal to 1. So using experiments 1 and 2, oxygen is first order. And then E says write the expression for the rate law. So rate equals K times NO raised to the second power times O2 raised to the first power. So we don't have to write anything. And then F asks us to determine the value of the rate constant. So pick any of these reactions, plug them into here, and calculate for K. Big thing is, on K, they always want you to indicate your units, so you need to make sure to keep track of the units. Well, if you remember the little shortcut that I told you, this is overall 2 plus 1, a third order reaction, which means it's going to be 1 over time. Since it's a third order, it's going to be molarity squared. So these are going to be the units. And in this case, the time is seconds. So we can replace the T with the seconds. So there's our units. So we don't have to worry about units anymore. So I'm just going to pick one. I'll pick the top equation. It really doesn't matter which experiment you pick. So 8.52 e negative 2 is equal to K times nitrogen monoxide is going to be 0.02 squared. Oxygen is 0.03, not raised, just raised to the first power. And so rearrange this and solve for K, and you get that K is equal to incorrect sig figs. We are allowed 3 sig figs. It's 7,101. And in order to get that to 3 sig figs, you would have to write it in scientific notation. So it would have to be 7.10 times 10 to the third to indicate that it's 7,100. And then the units, of course, are 1 over seconds molar squared, or you can say liters squared over seconds times mole squared. Or you can write it like this. This is acceptable. So that's that one. Select everything and delete and go on to the next one, which is going to be this guy right here. Go ahead and copy him and paste him onto here. Takes it a second and drag her down so we can all see it. Okay, so here's our last equation. You're going to notice, or last question, it's really similar in function to the first one that we just did. So determine the order of the reaction with respect to A. Justify your answer means show your work. So for A, we're going to use, let's see, B stays the same right here, so we're going to use experiments 2 and 3. And so A is going to be 0.136 over 0.034 raised to the n power is equal to 1.07 e negative 2 divided by 1.08 e negative 2. So 0.136 divided by 0.034 is going to be 4 raised to the n power. And if you notice, these two are the same number. 1.07 times 10 to the negative 2, 1.08 times 10 to the negative 2. That's the same number. And so this is going to be equal to 1. And in order to get something raised to a power to equal 1, that power has to be 0. So using experiments 2 and 3, A is 0 order. So what that means is that this reaction rate, the concentration of A doesn't matter. You could increase the concentration of A till the cows come home and it's not going to change this reaction rate. So for B, they want to know the order with respect to reactant B. So I'm going to go switch to blue here. B for blue. And for this one, we want B to change and we want A to stay the same. You notice these two numbers are pretty much the same. So we're going to use experiments 1 and 2. So use experiment 1 and a 2. And that's going to be B is 0.137 over 0.034 raised to the n power. 1.08 e negative 2 divided by 6.67 e negative 4. So work this out and you end up with 4 raised to some power is equal to 16, which means that n has to equal 2. So using experiments 1 and 2, B is second order. And then of course C is going to ask you to write the rate law. Big shocker there. Switch colors again though. So C is going to be rate equals K times B squared. A is nowhere in here because the rate is not dependent on A at all. D asks you to do the next thing that you probably predicted, which is figure out K. So for D, pick one. I'll pick the top one. 6.6. Actually, you know what? These two guys only have 2 sig figs. So I'm going to go ahead and pick these guys that have 3 sig figs. So let's do that real quick. Let me erase this. So I'm going to pick the 1.07. So there's our rate is equal to K times the concentration of B, which is 0.136 squared. So solve for K, and you get that K is equal to 0.579. They're real finicky about your units, so since this is a second order reaction, the units are going to be 1 over times molarity to the first power, because whatever this is, it's going to be, the molarity is going to be raised to a power 1 less than the overall order of the reaction. So our units are going to be liters per, let's see, this is seconds right here, seconds times moles. So there's K. E says calculate the reaction rate for experiment 4. Let's change colors once again. I like this changing colors thing. This is fun. So we're going to say rate, because that's what the question asks for, is equal to K. So 0.579 times the concentration of B squared. And so for this one, it's 0.233. and that's going to be equal to 3.14 E negative 2, and the units on this are going to be its molarity per second or moles per liter seconds. And then F, the following mechanism has been proposed, and then they want to know why. Give me 2 reasons why the mechanism is acceptable. Well, the first reason could be that if you took this one and added it to this one, that they would overall add up to this reaction because the E would cancel out and the extra B would cancel out, and so you're left with A plus B equals C plus D, which is exactly our reaction. Another reason that this would work is because the slow reaction, the rate determining step, has 2 particles of B participating, which is exactly what our rate law says, that we have 2 particles of B that have to collide. A third reason why this could be an acceptable mechanism is because in the slow step there is no A, and we figured out up here that this reaction is not dependent on the concentration of A. And so there's a third reason. So there you go, 3 reasons. You only needed 2, so pick any of those 2. G, in the mechanism in part F, is species E a catalyst or is it an intermediate, and justify your answer? Well, species E, let me switch colors again. Species E was produced in the first step and it was used in the second step. So anytime something is produced and then used, that equals an intermediate. If it was used and then produced, that's when it would be a catalyst. But this one was first produced and then used. So there's that. All right, now we have the multiple choice questions, which are right here. And some of the formatting on these questions is a little weird, but, you know, just go with it. Excuse me, sorry. What did I do with my questions? Huh. Oh, here they are. Sorry, I lost them for a second. Okay, on this first one, it says, what's the order of the reaction with respect to the iodine ion? Well, if you look at the rate that they have proposed here, or the rate law that they have proposed, you'll notice that I does not have an exponent, so it's raised to the first power. So with respect to A, whoops, sorry, I didn't mean to highlight the whole thing. With respect to iodine ion, it is first order reaction. And then they wanted to know what is going to be the effect if you increase the concentration on the hydronium ion. What's the effect? Well, you'll notice that the hydronium ion is in fact in the rate law. So if you increase the concentration of the hydronium, you're going to increase the rate. So that would also be A right there. And then on 28, it says, when the concentration of substance B is doubled, everything else being held constant, it's found that the rate of the reaction remains unchanged. So what that means is that substance B is 0 order. It's not that it's not involved. It is involved. It's just the concentration of B is not going to affect the overall rate. So we need to find something that says something like that. And after looking through all the answers, you'll see that C, sorry, I'm trying to highlight without highlighting the whole thing. C, substance B is not involved in the rate determining step, but it is involved in other steps. All right, 82 is one that I should not have put on here because it deals, well, the correct answer is not there. The rate law for this particular, scooch this over, and I think, no, I'm not going to be able to write. The rate law, here's your slow step right there. And so the rate law should just be the concentration of this guy. Rate equals K times concentration of that guy. But that answer choice is not there for some reason, so I'm very sorry for that. My bad. It happens. Typos. I'm sorry. Hopefully you were able to figure it out, though. 57. 57 says for the reaction whose rate law is given above. Rate law is right here. Bam, first order reaction. Which plot of the following, the plot of which of the following is a straight line? Well, when you have a first order reaction, that means that the straight line is going to be the natural log of the concentration of X, and so you just need to find one that deals with log. So that would be B. I know it's log and not natural log, but it's still a logarithmic function, so log of the concentration of X versus time is going to be your correct answer right there. Okay, moving on to the next one. 58 says that you have this crazy looking reaction right here with this proposed rate law, and they want to know if some solid, put solid twice, if solid sodium hydroxide, solid hydroxide, oh, that's so weird, is added to this solution, which of the following is going to be true? Well, we added solid sodium hydroxide, so what is that going to do? Looks like they're looking at rate and they're looking at K. Well, looking at our rate law, you might notice that sodium hydroxide isn't in it. And so that means the concentration of sodium hydroxide is not going to affect our rate, and it's not going to affect K. And the only answer choice that shows that is C. 17. Slow rates of chemical reactions are associated with which of the following? Well, the presence of a catalyst, the purpose of a catalyst is to speed up a reaction, so it's not going to be slow anymore. Increasing temperature tends to increase rates, so not going to be a slow rate here. High concentration, the higher the concentration, the faster a reaction tends to go because there's more of the chemical species to react with each other. Strong bonds in the reactants. If the reactants are very strongly bonded, then they are not going to break those bonds very easily. And so that is, in fact, going to lead to a slow rate. So D is looking pretty good. And then on E, if we had a low activation energy, then that would mean that the energy required to get the reaction started is low, which means it's going to be easier to overcome that activation energy, which means a higher rate. So the only one that indicates a slow rate of reaction is D. Okay, on 23, we've got these proposed steps of a catalyzed reaction between cerium and I think this is thallium or thulium. I don't know. I don't use that one often enough. And they want to know what are the overall products. So what you got to do, look at these three reactions and see what can be canceled out. Well, let's see. I see 2 cerium 4 pluses. I don't see any cerium 4 pluses over there, so those can't be canceled out. I see an Mn2 plus, see an Mn2 plus, so those guys can be canceled. Mn3 plus, Mn3 plus, those guys can be canceled. Mn4 plus, Mn4 plus, those guys can be canceled. I see a TL with a +1 charge. This TL has a +3 charge, so those cannot be canceled out. And then these 2 ceriums each have +3 charges, which do not match these charges over here. So it looks like all the manganese ions are your catalyst, which makes sense because manganese is a pretty good catalyst. And it's the cerium 3 plus and the thulium 3 plus that are our final products. So there's your answer right there. Okay, isomerization, love that word, of cyclopropane to propylene is a first order process with a half-life 19 minutes. The time it takes for the partial pressure to decrease from 1 to 0.125 is closest to. Well, I'm going to go ahead and go off of this. Let me just copy this. And we're going to go over here and work on that one. Oops, pushed the wrong button. Okay, so here is our question, and they give us quite a bit of information that we don't really need, such as, okay, great, temperatures match up, so we don't need that information anymore. And then they want to know isomerization of cyclopropane to propylene. So that means our reaction is, we'll call cyclopropane CP, going to propylene, we'll call that PY. So it's basically the decomposition of cyclopropane into propylene. And so if we start out with the cyclopropane partial pressure of 1 atmosphere and it decreases to 0.125 atmospheres, well, you might remember from our gases unit that the pressure of a gas and the number of moles of a gas is directly proportional when the temperature is kept constant and the volume is kept constant. Well, we can assume that this is in one container. So if they're telling us that a half-life is 19 minutes, that means that every 19 minutes, half of the cyclopropane will have decayed into propylene. So that means after 19 minutes, we went from 1 atmosphere to 0.5 atmospheres. Because half of the moles of cyclopropane have decreased or have decomposed, which means half of the pressure is going to be gone. After another half-life, we're at 0.25 atmospheres. And after a third half-life, we're at 0.125 atmospheres, just each time dividing it in half. So at this point, we match. So we've had 1, 2, 3 half-lives. If each half-life is 19 minutes, multiply that by the 3 half-lives we had, and we end up with 57 minutes, or that one. Okay, coming back here. 63 asks us, according to the results, which of the following can be concluded about the rate law for the reactions under the conditions studied? You'll see that the concentration of Y stays constant, and the concentration of X slowly decreases over time. Doesn't give us anything about the concentration of Z, but the fact that the concentration of Y doesn't change as X changes means that the reaction has to be 0 order in respect to X, because changing concentrations of X have no effect on the concentrations of the other parts of the reaction. And then last but not least, and we are going to copy this one and put it into our little thing here. How on earth? There we go. See? I love this little program. It's just sheer awesomeness. Select all of them. Alright, so here is our little question. A little worse for the wear when it comes to formatting, but you know, you can get the general gist of it. They want to know what's the experimental rate for, rate law, that's law, there's a W in there, for the reaction. So all we have to do is figure out the rate laws, the rate orders with respect to each of these 2 reactants, which you guys should be getting pretty good at by now. So with NO, with nitrogen monoxide, it looks like we're going to use experiments 1 and 2. So 0.2 over 0.1 raised to the n power is equal to 5e negative 4 over 2.5e negative 4. No calculators on this part. So you see 2m is equal to, basically these e to the negative 4s are gone, so 5 divided by 2.5 is 2. So m equals 1. So we can cross out C and D. And then with relation to O2, we're going to use, looks like experiments 2 and 3, because those are the ones where NO is kept constant. So 0.4 divided by 0.1 is equal to 8e negative 3 divided by 5e negative 4. So this is going to be 4, sorry, this is raised to the n power. 4 raised to the n power. This is basically 80 divided by 5, which is 16. So n has to equal 2. So our rate law is going to be equal to K times NO times O2 squared. So that is going to be B. And I believe that is all of them. Yeah, finished in under half an hour. If you continue to have any questions, you know how to find me. Remember, we will have this kinetics test on the next day that we are in school, whether that's tomorrow or I don't see you guys until Friday, whatever it is. We will be there and take that test. But if we do not have school over the next couple days, you guys absolutely must start the equilibrium chapter on your own. So we'll just see what the future holds.